Hello, I'm Cullen Gunn, CEO of Kilter Rural. Kilter Rural views climate change as the key risk and opportunity for farmland, water and ecosystem investments. Using available information, our position is that we need to prepare for a climate 2 to 3 degrees warmer than it is today. In order to guide our climate adaptation approach, we asked Professor David Karoly of Melbourne University to present to Kilter Rural on the likely impact such a changing climate may have.
There are choices that have to be made in almost all sectors about how you're going to deal with risk. Australia has to face a range of issues, risks. Climate change is just one of them. So does the planet. Well, should I say the governments of the world. And they've actually met, and I'm going to talk a little bit about this later on, they met and agreed. We don't have a choice for the just right planet any longer. We have a choice between one which is, it's not a boiling hot planet, but it's certainly a lot hotter, and one which is least hot. But we don't have something that was just right. Recognising that is important. Global average temperature variations. Temperatures go up and down all the time. Separating the longer term trends from year-to-year variability and trying to understand those is critically important. This is the conclusions from the most recent comprehensive science assessment from the Intergovernmental Panel on Climate Change, and it's the most comprehensive scientific assessment of anything in any topic. The conclusions have just got stronger and stronger. This body was set up in 1988. First assessment was in 1990. This is the fifth assessment report. Warming of the climate system is unequivocal. There is no doubt the climate system's warmed. That human influences have been the dominant cause of that. The climate change is going to continue. There's going to be more frequent hot extremes and fewer cold extremes, and that's the most confident conclusion, as well as changes in temperature, and I'll show some more of that. And that, unfortunately, extreme precipitation events, heavy rainfall events are going to increase as well. So what's happened in Australia over the last 50 years? Let's look at temperature first of all. If you look at this sort of year-to-year variability in temperature in Australia, as you go to smaller regions, the variability is bigger. So when you look at Australian temperatures, we actually have a similar magnitude of warming, about 1 degree Celsius, but it's over the last 50 years, not over the last 100 years. But there's also variability from year to year and variability from decade to decade. The magnitude of the warming is about 1 degree. It wasn't quite as much warming in the sort of 60 to 70 period, but it's about 1 degree. This is the trend map. Somewhat reduced warming around the coastal areas, but particularly reduced warming in the northwest of Western Australia, more warming in inland areas. And that's exactly what you find on the sort of year-to-year timescale. The variations are more moderate in the coastal regions because the oceans warm up more slowly. So we should be talking about global average land area if we want to know what's relevant for farming and for where people live. It's 25% larger warming on land than the global average. So when we're talking about 2 degrees of global average warming, we're actually talking about 2.5 degrees on land. That's what we're accepting is the target. So let's look at rainfall, as important or more important than temperature variations. And the rainfall variations here, drying in the southwest of Western Australia, drying in much of the southeast, some drying up the east coast. This is probably natural variability. But up here in the northwest, it's getting wetter. Wetter in the north, drier in the south is what we'll see later on is the projected change in Australia. But notice that where it's got much wetter in that region to the northwest of Western Australia and Northern Territory is where it's got colder. If it rains more and there's more cloud, you get less sunlight, it's colder. That's primarily due to changes in the atmospheric circulation. That sort of local regional effect is just part of natural variability. So not everything we see is due to human-caused climate change. Some of it's just random fluctuations. Southeastern Australia. Much of what your business is around is water resources and farming. And what's happening to rainfall is key to that. This is summertime rainfall, southeastern Australia since 1900, 2010-11. It was wet, it flooded, and it flooded again in 2012. That was the most extreme. Overall rainfall has been pretty flat, although if you look at the averages, there's actually a slight long-term increase in summer. Offset by the fact that the last 5 years, and much of the last 20 years, has been dry in the cool season. There was a wet period in the 50s, the 40s. The sort of World War II drought was also very dry. The Federation period, 1895 to 1905, was also very dry. Those tended to be summertime droughts as well as somewhat reduced in winter. But the big difference now is dry in winter and about the same, or possibly even in some regions, wetter. And as you go further north, it's actually tending to get wetter in summer, drier in winter, which has major impacts on farming and major impacts on water resources, because more rainfall in summer doesn't necessarily help your water resources very much. We see, not just in Australia, but across the planet, poleward shift in ecosystems, as well as an upward shift. In a warming climate, that's exactly what you would expect, because the ecosystems are essentially adapted, evolved for a certain climatic zones, and those climatic zones are shifting poleward and upward. We can see it with plants, we can see it with insects, we can see it with animals. We actually see what's called phenology, is the timing of seasonally dependent events. Basically, plants are flowering earlier, animals, birds are migrating earlier, insects are hatching earlier. You can see it throughout Australia as well as in many other parts of the world. And it has major agricultural implications. In some areas, this can mean a longer growing season, and higher carbon dioxide has led to a net increase in natural primary productivity in plants growing more, which is taking up more carbon dioxide than would have happened if the climate had less carbon dioxide in it in the first place. So if you measure, for instance, plant growth in the Northern Hemisphere, it's expanded, it's growing more, but not enough to take up all the extra carbon dioxide that humans are putting into the climate system. Of greater local impact is the increases in bushfire frequency and intensity throughout much of southeastern Australia. Southeastern Australia is one of the most bushfire-prone regions of the world, and it's got worse significantly in the last 40 years. Farming corals yet, although we use it a lot for both tourism and for fisheries, it's critically important. And this year, because of the warmth associated with El Nino in the tropical Pacific and its impact on the Great Barrier Reef, we've had record temperatures in the Great Barrier Reef and record coral bleaching. Coral bleaching had never been observed anywhere in the Great Barrier Reef, and it's been monitored a lot prior to the 1980s. Hadn't been observed anywhere in the world at a significant level, and we've had major bleaching events. Coral bleaching will be occurring every second year in 2034, so if you want to see a living reef, go before or in the next 10 years. Climate change is happening. It's mainly due to human activity. It's mainly due to burning fossil fuels. We can use the same sorts of climate models that we've used to understand what's happened in the last 100 years to look at what's likely to happen in the future. We use two different scenarios. A high warming scenario, in some sense a business as usual scenario, and that's this scenario. This is from 1950 to 2000, about half a degree of warming, and this is substantially more. And this is the scenario that stabilises global average temperatures to meet this Paris commitment. Even then, we've got to recognise that's a very rapid emission reduction scenario. It's artificial. It's a scenario where we've put into climate models feasible potential emission reductions, but there's no real commitment that the governments are going to achieve those. It's important to understand these are uncertainty ranges, and this spans 2/3 of the probability range. So this one gets up to 5.5 degrees, but notice this is a clever scale. It's 0 here is centred on 1995. You can't see that, I just know that. There's already been 0.6 of a degree warming relative to pre-industrial. What this means is 5.5 degrees of warming relative to 1995, more than 6 degrees of warming relative to pre-industrial. Multiply that by an extra quarter, or 1.25, to get 7.5 degrees average on land. The planet hasn't seen that amount of warming for more than 5 million years. Homo sapiens have not seen that amount of warming on the planet. It's a very different planet. This looks like a best estimate of 1 degree of warming, but here we are at 1.5 degrees or 1.7 degrees of warming relative to 1995. Add the 0.6 of a degree, it's above the 67% range. It's actually a 17% chance of temperatures greater than that occurring. And so that's a 17% chance of temperatures up to 2.3 degrees. That's for a rapid emission reduction scenario, and I'll come back to what that means. But so you shouldn't rule out even global average temperatures above 2.5 or above 2 degrees. So what's happened and what's projected to happen in Australia? Well, here's the high emission scenario, and there's a fair lot of red there, and that's 4 degrees or more. It's easier to see for this one. This is the middle of the 21st century, and here's the low emission scenario. So this is 2050, this is 2100. Even with this scenario, there's temperatures of the order of 2 degrees or more throughout much of the country and a lot of farming area, except, well, particularly in the Murray-Darling Basin. Low emission scenario, it's pretty much the same in 2050. It's stabilised by about 2050. We're talking about temperatures around 2 degrees on average across Australia. That's still substantial warming in a different climate than we have at present. Rainfall, climate change due to increasing greenhouse gases primarily directly drives temperature change. Rainfall change happens associated with the way that the atmospheric circulation and the moisture content in the atmosphere changes in response to that warming. So a warmer atmosphere means more moisture in the atmosphere, but the circulation patterns change. There's also a lot of natural variability in rainfall from year to year. We talked about that very wet period in the 2010, 2011, 2012, and then the drought in 1990s up to 2009, 97 to 2009. This shows projected rainfall change for the high emission scenario and the low emission scenario, 2050, 2090. Diagonal lines indicate no consistent pattern of agreement, even in the sign of the change between the different climate models. Not the magnitude of the change, the direction of the change. So based on this, there is no confident information about rainfall change in the middle of the 21st century from any of the climate models. The only regions where there is some agreement is in the southwest of Western Australia and actually in southern Australia as well. But there's still large uncertainties and large natural variability. And so projecting rainfall change, it's natural year-to-year variability that's going to dominate on the short timescales for the next 30 years and will dominate on longer timescales as well for many of the different things. So here is some information. What period should you be looking at as an average? So the real question is, when I looked at the changes, like over the last 50 years, what we're seeing is already changes entirely consistent with the projected climate change for southeastern Australia, both in terms of climate, but also the projected impacts. I'm going to show some quick results from this website. I don't know if any of you have used it. It's called climatechangeinaustralia.gov. This is the projections for Bendigo. This is for a high warming scenario where in the current Australian climate looks like what Bendigo will be in a warming scenario in 2050. 2050 is not far ahead. It's still in the sort of range that you guys are trying to look at. And, some of these places, it's a bit further west. But wait a sec, we're talking about, inland New South Wales, particularly still good farming areas, but it's a lot hotter. And you look at the average and you're talking about a 300 to 500 kilometre southward shift in the climate. That's a change. This was a very powerful graphic of climate change risks for Victoria. This one is supposed to talk about climate change risks for Victoria sometime in the future. But think about these in the context of what we've experienced in the last 10 years. Increases in bushfires, impacts on irrigated agriculture, and particularly decline in water availability for irrigation, increases in the number of very hot days in Melbourne and throughout Victoria, decreases in wintertime rainfall, decreases in snow cover, and increased erosion on the coastline. Climate change isn't something that's going to happen in the future. Well, it is going to happen in the future, but it's happening now and for the last decade or more. It's not something that we have to worry about just for our grandchildren. It's actually something we have to worry about for our grandparents as well. So it's not something that is distant future. It's actually something we were worrying about and dealing with. It's just that for many farmers, they've been dealing with it for 10 years and describing it as natural variability. We now know it's not just natural variability. Climate change has an enormous range of impacts. Water resources, what you guys are worried about. Reduced stream flow and reduced water for irrigation, particularly associated with the declines of water in winter. Availability of water in summer because of the reductions in wintertime rainfall. Agriculture, warmer, longer growing seasons, southward shift, potentially some benefits from higher CO2. But for agricultural production, that actually has impacts on protein content in grains. This is to do with the reductions in nitrogen uptake. And I'm not an agronomist, so I can't tell you all the details of that. There are other impacts. For human health, hot extremes. It's tough to farm outdoors when it's 45 plus Celsius. And we're getting a lot more of those days. There's also, with the increased heavy rainfall, increases in erosion, increases in flooding. And both of those have impacts on, well, farms, on water resources, on all the systems. Talking about infectious diseases under human health here, but actually insect pests dramatically increasing for agriculture as well, because it's not as many extreme cold temperatures. Winters are warming faster than summers on average. The insects are surviving through, and so that's why you get more European wasps. They're not dying out as much. We don't have European winters. These changes shouldn't be seen as just a problem. They're a management opportunity. And if you know about the information and you plan for these changes that are happening already, in practice, you can make a buck, or even a lot of bucks, out of this. And so the opportunities dealing with farming practices, think about what crops, what livestock varieties will flourish in a drier and warmer climate. Birchip Cropping Group has flourished in northwestern Victoria by taking advantage of opportunities for dryland farming. You know, you probably can also take advantage of either real or potential opportunities for increased soil carbon and increased trees through the Carbon Farming Initiative, or ERF. There may be some opportunities to make money from farming carbon. It is going to be critical, both in Australia and globally, if we're going to address climate change, that farming and land use has to be a critical part of the solution. Not just responding to it in terms of coping with it, it's actually part of the solution as well. And then in terms of water use efficiency, there's lots and lots of things that can be done. I know you're doing this already. There's improvements in irrigation, in terms of reducing evaporation, capturing water, better water use efficiency. What is assumed in this low emission scenario? This is globally. We're currently emitting around 45 billion tonnes of carbon dioxide per year, and we're going up to more than 100. This is that low temperature scenario. This has zero net emissions globally by 2080, but in agriculture, all of those scenarios have positive emissions from agriculture. So it actually has zero net emissions from fossil fuel burning, all those scenarios, or negative emissions before 2070. And for Australia, best estimate is if we try to do our fair share of emissions reductions, Australia has to go to zero net emissions by 2050 or earlier, with positive emissions from agriculture and negative emissions from whatever way we can do it, which might be farming, soils, planting trees, some other technologies. But that is rapid. Why does it have to be so rapid? Well, carbon dioxide in the atmosphere from burning fossil fuels cycles around from being burnt fossil fuels into the atmosphere, and then it goes into plants. But when the plants die, the trees die, it goes back into the atmosphere, it degrades, or it gets taken up into the upper layers of the ocean and then it gets cycled around. Long-term removal of the carbon dioxide requires either for the carbon dioxide to be mineralised into rocks or to get into marine sediments and in the deep ocean. Both of those are long timescale processes. Long-term removal, what we've added, about 100 parts per million of CO2 in the last 100 years, 10% of that will still have led to an increase, or the concentration will only reduce by 90% of that, 90 parts per million, in 10,000 years. This is a long-term problem. What that means is that the cumulative emissions of carbon dioxide are what drives climate change, not the emissions in any one year. So if we defer reducing CO2, then that adds more carbon dioxide to the atmosphere and that commits to more warming. This then leads to a concept of something called the carbon budget. How much carbon dioxide, or carbon in this case, can we emit if we are to have a 65% chance of staying below 2 degrees? Still a 33% chance of dangerous global warming of more than 2 degrees. So that gives a number of 790 billion tonnes of carbon. And you multiply by 44 over 12 to get the amount of carbon dioxide, but don't worry about the arithmetic. That gets reduced because we've burnt a lot, 515 billion tonnes. We're left with 275 billion tonnes. 9 billion tonnes of carbon per year is the annual budget that would blow that. That's what our current use is. It's actually more like 9.5. That's 30 years, the current rate. What's Australia's emissions per person? Well, you'll often hear a number of, what Australian emissions are more like 25 tonnes of CO2 equivalent per person per year. So this is 1.2 tonnes per person of carbon. Take the Australian emissions, CO2, not CO2 plus methane plus others. It's closer to, again, this 7 tonnes per person per year, not 25, but it's reduced because we're converting it to carbon, not CO2. We're emitting dramatically more than the global average, disproportionately more. We have 1.4% of the global emissions and 0.3% of the global population. We have 5 times more than the global average, 10 times more than the emissions in India. Australia is emitting disproportionately large amounts. What can we do? We can improve carbon sinks, which involves agriculture and soil carbon. We can also use much more efficient low carbon energy sources like solar power or wind power. And that's also important in terms of regional areas because some of the sunniest parts of Australia are some of the land that you're managing. A number of assessments have been done, both for Australia and globally, of what would be the cost of introducing climate change action. And the assessment is that for typical business as usual economic growth of 3% per year, and current growth projected in the most recent budget, 2.5%, the impact of completely addressing climate change is a 0.06% cost. Not 0.06% of 2.4%, but 0.06% subtracted off 2.4%. So instead of 2.4, it would be 2.34. Or 2.5, it would be 2.44. So what does that mean if you think about it? Well, it's about a 10-day delay in being as rich, individually or for the nation. It's a 10-day delay and you've solved climate change. Now, it's a 10-day delay every year, so after 40 years, it's a lot of money. So if you just want to point out how much money it costs, then you talk about, well, in 40 years' time, this will cost a whole year's growth in the economy. It's a big number in billions of dollars. Or alternatively, you say, actually, we could solve climate change by avoiding all the costs of climate change and a 10-day delay in economic growth. Yes, there will be major impacts. There aren't a lot of businesses making horseshoes anymore. And yet, in 1890, there were a lot of horseshoes being manufactured. They lost their jobs. So we've got to recognise that there are jobs involved in the fossil fuel industries that will need to change.
David's presentation highlights that significant future challenges exist for all of us. As direct managers of real assets, Kilter is driven by the chance to deliver real and lasting change in how assets are managed to mitigate impacts from a warming climate and reduce risks to both investors and natural ecosystems that underpin long-term value. If you'd like further information, please contact us using the details provided.